Hello and welcome to VoltScript Ventures. My name is Devin Olson, but you can call me Spanky. I work with an incredible team here at HCL Labs, and in this video I'm going to introduce you to one of our VoltScript VSS libraries. Welcome to VSS Libraries Part 02, the VoltScript Collections Library. So, VoltScript Collections Library, what is it and why do we have it and why do we produce it? Well, for those of you who've been around writing Lotus script for a number of years, you're probably very familiar with the Lotus script array and the Lotus script lists, and they are extremely useful and extremely valuable. They have their place, but they're not really robust enough for our goals. Remember, our goals are to be simple and easy to use, and arrays are very good at what they do, but there are obviously some limitations. Lists are extremely performant, but again, there's some limitations. We have collections and we have maps, and one of the advantages of our collections and our maps classes that we decided that we put together, some of our rules that we set upon ourselves, is we wanted them to be very standardized, very similar to one another. So they have very clearly defined valid content types. We have very specific rules about what you can and cannot put into a collection or a map. We have sorted and unique options, meaning you, the developer, through setting of certain options, can control whether a collection or a map is sorted or unique. We focused heavily on simplicity and ease of use. They are, of course, extensible, and they are, of course, open source, and they're available at github.com, HCL Tech Software, VoltScript Collections. You can go out there right now, today, pull this code down and look through it. So, I talked earlier about valid content types, and we have very specific ones, as I said before. All collections and all maps can contain anything here that I'm going to define. So any of your standard base scalar types, a string, an integer, a long, a single, double currency, those numbers. What else can we put in? Well, we could put in any defined class. So an object instance of any previous defined class in your code, you can put into one of these things. You can put any scalar in. You can put any object in. Mixing types are allowed, but with some certain restrictions. And to talk about those restrictions, we're going to look at this. What are our content types that are restricted? First and foremost, variance. Wait, that's the single most common data type used in Lotus script. Why would we not allow that in VoltScript and in our collections? Well, the reason why is because the variant is a generalized carrier for any type of data, meaning I can declare something as a variant and I could set a value to it that's an array. I could set a value to it that is a scalar. I could set a value to it that is actually an object. I could set any type of value to a variant. And more to the point, I can mix variables of different variants. So I can have one variable that's a variant and another variable that's a variant. I could set one equal to an array or list. I can set the other one available to a string. And if I try to put these into a collection, they're different and there's different rules how you interact with them. It makes the code very complex to make it robust enough to handle that. And more to the point, you can't test in VoltScript or Lotus script the data type of a variant as a variant. And what does that mean? If I say dim foo as variant, and then I set foo equal to a string, and I do a type name on that, it will tell me it's a string. It won't tell me that it was a variant. It won't tell me what it was when I declared it. It only tells me what it is at that moment in time, and that's messy for carriers of elements. So we just simply said, you know what? You're not putting a variant in. If you want to use your variant in a collection or a map, well, you must explicitly declare what that variant is going to be. So maybe you have doom foo as variant. You set it something. Say you set it to a string. Well, then you create another variable, dim bar, as string. Set the value of bar equal to foo. Throw bar into the collection, and it'll work just fine. So that's a really important rule. Well, what other things are restricted? Scalars mixed with anything else, not allowed. Objects mixed with anything else, not allowed. Meaning, if I have scalars, they all have to be scalar. If I have an object, they all have to be objects. That's critically important. We do not allow null, empty, nothing, an array, or a list. Why? Because it makes creating these base level classes very complicated. It makes the underlying library very, very large. We have to put a ton of code in to be able to handle those relatively exception type things. So it's better to just simply not allow it. So if you try to create a collection, or you try to create a map, and you try and throw something in that's empty or an array, it's not going to let you. You're going to throw an error. Sorting and comparing. When we sort a collection, we sort it during insertion, meaning every single time you add a new element to a collection, if that collection is sorted, we sort the collection at insertion time. Why? Because you tend to ask for things from a collection more often in code than you put things into a collection. It makes programmatic sense to sort on insertion and not when you pull it out, because if we sorted when you pull it out, then we're going to sort many more times. Sorting takes time. We want this to be efficient and easy to use, so we sort during insertion. And how do we sort? Well, we use the comparator class, but the comparator is the thing that we use to compare stuff. So what are our classes in our collections library? Well, there are several, and I don't have all of them listed here, and I've kind of combined some of them. There's a bunch, and if you go to the documentation on the GitHub site and look at the API documentation, you'll see there's a bunch. But the primary classes that we care about, we have the collection. That is the carrier of things. We have a map. Well, what the heck is a map? What's the difference between a collection and a map? Well, a collection is a carrier of things. A map is a carrier of things and keys. So a map has what in there. It has a key that points to a thing, and then it has that thing. Okay, cool. We have a pair. Well, what is a pair class? What is a pair? Well, a pair is a base class consisting of a key and a value, and that's used for defining an element in a map. And we've decided that it's immutable, meaning the key and value can't be changed once you create them. You can access them via dot notation, but they're read-only property. What else do we have? Well, we have a comparator. What's the comparator class? The comparator class is the class that we use to, you ready for this? Compare values when we put them into a collection. So if we're going to do some sorting, or we're going to do some testing, is this equal to that, or is foo equal to bar, or is foo greater than bar, or is foo less than bar for doing certain sorting? We create a comparator. A comparator is a base class. It's designed to be extended because VoltScript and LotusScript, which predicated it, doesn't allow for introspection, so we can't do deep level introspection into your object instances when you're putting them in. So you have to extend the comparator class to tell the code how to compare two things that you want to put into a collection. We have filters and we have transformers, meaning we have collection filters and collection transformers, and we have map filters and map transformers. Well, what are those? Well, a filter is something that we use to filter elements in either a collection or a map, and we had to do them they're separate, so there's not just a filter. There's a collection filter, there's a map filter, and the class is used to filter elements. So like, say I have a collection consisting of 200 elements, and there's some elements that have differences to other elements, and I want to get a certain subset of those. So I'm going to filter the collection. The filter object, that class instance that I create, allows me to filter out the content and get the ones that I want. Okay, so what's a transformer? Well, a transformer is a class that you use when you transfer elements from one collection into something else. Could be another collection, could be a map, could be something, some other type of output. You use your transformer class, okay? And then we have the same thing for maps. We have a map filter and a map transformer. And the reason why is because collections and maps, their base classes are somewhat different. We do have some other classes, some other specialized classes within the library. I'm not going to get into those during this quick demo and introduction, but again, when you start playing with this, you can learn quite a bit about them. Okay, let's go ahead and start our demo. So here I have my Visual Studio Code development environment. It is set up to do some demonstrations here for VoltScript Collections. Real quick, there's my atlas, collections demo, VoltScript Collections demo. I'm pulling down from HCL GitHub, and I'm pulling the latest release of VoltScript Collections. I pulled that down, ran it, created my effective atlas, generated my SETI, and I'm ready to start coding. There's my VoltScript Collections Library and all my other backend dependencies, all from that. So again, as a reminder, if you haven't watched Rocky's video on archipelago and dependency management, you might want to take a look at it, as it's critically important. So let's go ahead and close these. Yeah, we'll save that atlas JSON. And let's jump into my main. Here's my main library for the demo that I want to start playing with. And let's see what we're doing. So option explicit, I'm using my VoltScript Collections Library. Subinitialize, this is the first method that will be run when we decide to run this. And what are we doing here? All right, well, I'm dimming call as a new collection, and I'm passing in some arguments. What are those arguments? Let's take a look at our documentation for a collection. And for the new method, argument 1 is content type. Well, we've said scalar. It's one of our keywords. That means any scalar value is allowed in the content, so I can mix things up as long as it's scalar. Second argument is a comparator. I'm not doing any comparison, which means this collection will be not necessarily sorted, so must be unique, and sorted arguments are both false. Okay, so far so good. Here we go. I'm dimming I as a long. It's just I want to count things, no big deal. And then I say, okay, add the word hello, add the word world, and then let's do this quick loop through all the code. Print out collection.getElementsRaw at I. I is dimmed, so it starts out at 0, while ++I is less than the element count, taking advantages from a new shortcut notation in VoltScript. Let's go ahead and run this and see what it does. And we'll walk through VoltScript, save and run script. Go. Pretty simple. Hello world. So far so good. It's just like dealing with an array or any other type of collection. Not that amazing. Let me grab this, scroll this down. Let's add a little bit more code to this and have some fun. I want to go ahead and I want to add other data types. So let's go ahead and paste in some more add lines. I want to add the numbers 1, 2, and 3, and then I want to add hello again. Remember, we said must be unique is false, so we can add the same thing more than once to my collection. Go ahead and run this. And look, we got hello world 1, 2, 3, and hello. Wow, that's kind of cool. Well, let's get even more crazy, and let's have a little bit more fun. Let's create, oh, I don't know, how about an array of doubles? Drop that code right there. So doubles 0, 1, 2, and 3 is just some interesting numbers in there. And so if I repeated this do while real quick right here and pasted that there, and we said do while I++ is print VLS sub I, while I plus plus is less than or equal to U bound of doubles. There we go. I equals 0. Try that again. Clear that so there's no confusion. There we go. There's our values that we put into doubles, and then there's the value of the array. Well, let's have some more fun. Let's get rid of this, and let's get rid of this, and let's add the doubles to the array. Now, I could add them one at a time, or I could take advantage of the add all method and add all the doubles to my array, or to my collection. Ready? Set. Clear this, and go. Well, isn't that interesting? Very cool. We got our hello, our world, our 1, 2, 3, the second hello, and then all the values of doubles just dropped in. Super simple, super easy. That's pretty interesting. Let's have some more fun. We're going to get crazy. All right. Let's pay attention to what's going on here real quick. This is fun. So if I run this again, this print is going to print this exact thing again. But now I'm going to say, hey, I want you to insert at, and I want you to insert this value new at position 1 in my collection. And then I want you to print out the collection, but join it with some commas. What the heck? Can we really do that? Why, sure we can. So there we go. There's the initial collection. Let me scroll this up so we can take a look at it a little bit. Oh, clear all this and run it clean. Boom, boom, boom. Look at that. So we got hello world 1, 2, 3, hello 1.23, 2, 1, 4, blah, blah, all that stuff. Hello. The word new has been inserted, and then world and all the rest is all in there. And so if we, instead of joining it, we just did this here and did it there, and we're going to say, and just to make it really clear for everybody to see, print joined with a comma, and there, let's run that, clear, and Command Shift P, boom, boom. Look at that. So there's a value joined with a comma, there's the new stuffed right on in. So pretty simple, pretty easy to do some very basic functionality with your array. We can even get even crazier. I could say, you know what? I want you to reverse it. And let's say here, and now run it again. Boom. So we printed everything out, then we reversed it right there, and then joined it, printed it out, joined, and now it's in reverse order. Okay, so that is the end of our collections demo. Let's go ahead and move to the next demo. VoltScript maps. Pretty simple, cool stuff. So let's close this and close that. Let's open up our maps demo. And here we have very simple maps. We're using the same library, and we're going to create a map as a new map. And something important, I want to talk about that constructor. So back to our documentation, here's the constructor for the collection, and we have a content type, a comparator that compares the values, a flag indicating if the values must be unique, and a flag indicating if it's sorted. The map, extremely similar. If we come and look at our constructor for the map, we have a content type, just like in the first one. We have a key comparator. So the difference here is the comparator is going to be used to compare keys in the map, and then a flag indicating whether or not the map should be sorted. So we're comparing keys, not values. There's no must be unique flag because that really doesn't apply to a map. It's not necessary. So let's come back here, and we're going to say we're creating a map as a new map. We're passing in string content, no comparator, so all the default. It doesn't need to be sorted. It's pretty simple, and just an eye for us to iterate. quickly to get values, and we throw some values in. Key value, key value. So IO is the key, Iowa is the value, NE is the key, Nebraska is the value. I think you can figure the rest out. Quickly demonstrate that, see what we do. We load everything up, we go through the loop, Arizona, Florida, Iowa, Nebraska. Pretty simple. That's not that complicated. It's pretty clear cut. And if we decide to add another element, and so now we've got California and California twice. And if I run it again, you'll notice there's only one California. Why? Because the same key. Okay, you're putting at key California. So, okay, let's go on and try and create a sorted map and talk about sorting a map. So you can't change an existing map from non-sorted to sorted, but what you can do is just create a new map and put everything from the first map into the new map. So it's not that complicated. It's pretty easy to do this. So let's do this real quick and show how this is going to work. So right here I'll print a blank line and I'll set I equal to 0, and then we'll paste that loop back in, and instead of map we're going to change this to map 2 and map 2, and let's clear this so we've got a clear thing. So basically what I'm going to do is I create a new map and I say it is sorted. So I want a sorted map, and I'm going to put everything from the first map into map 2. I'm going to print a blank line, set I to 0, and then we're going to print out everything in the new map. And we don't need this additional line here because it's just extra work. So let's run that real quick and see what we get. So here we go. There's the first map. Boom, boom, boom. Here's the second map. Sorted. Awesome. Alabama, Arizona. It's sorted on the key. Okay. Let me make Arizona's key to AAZ and run that a third time. You'll notice no, it's Arizona, Alabama. Okay, because it's sorted on the key, not the value. Again, pretty simple. We can do some additional fun things. We can reverse a map. So let me do that real quick here. And we're just, now that we've got the map 2 done, we're going to reverse it. Then we're going to throw a thing in, do the same thing, but I do need to stick this in for the demo and paste that there. And let's run that real quick. Boom, boom, boom. So here we go. There's our first map. There's the second map. Now we've reversed it with Washington stuck in and changed the sorting. So a sorted map you can reverse very easily. You just can't change from one map to another. So that's kind of it for a very simple map demonstration. There are a whole bunch more crazy, awesome, cool things you can do with playing with filters and comparators and changing values and transforming maps from one thing to another, transforming collections from one thing to another. Don't really have time to go into that for this introductory demo, but I do urge you to go out and pull the code down and check it out. Play with it. It's a good time to learn and have fun with new stuff. Once again, my name is Devin Olson. Thank you very much for joining me on this quick tour of VoltScript Collections.